This is question number 3 from the Introduction to Limits Notes, section 2.1. And in this question, we're being asked to sketch a possible graph that meets the following conditions. So possible graph, that means that there's lots of right graphs I could draw. What I'm about to draw might look different than what you draw or what your classmates draw, but we can all be correct as long as we meet the given conditions. So we have 3 conditions given to us. The first condition says that the limit of the function as x approaches positive 3 from the left has to be a height of 2. Now remember, f of x is an output. It's the output we get when we plug x into the function and follow the rule, and the number comes out. That's the output. It's also the height of the graph. So as we approach x equals 3 from the left, the height of the graph approaches 2. And now our second condition says as we approach the input x equals positive 3, but this time from the right, the height of that graph is going to approach negative 2. So as we approach x equals 3 from the right, the height of the graph is going to approach negative 2. Okay, so condition 1 tells us what the height of the graph is doing as we approach x equals 3 from the left. Condition 2 tells us what the height of the graph is doing as we approach x equals 3 from the right. But what's happening at x equals 3? Well, that's what condition 3 tells us. When x is actually equal to 3, the height of the graph is negative 2. So I'm going to start by plotting that point. So let's come locate x equals 3 here on my graph. And according to condition 3, the actual height of the graph, when x is exactly equal to 3, is going to be negative 2. So I'm going to go to negative 2 and I'm going to plot a solid dot there, a solid point, because that's where my function is defined when x equals 3. The output's defined to be negative 2. And then I'm going to draw a dashed line here for a minute. This isn't really part of my graph. But what I'm doing with this dashed line is I'm separating the outputs on the left side of my equation from the outputs on the right side of my equation. Okay, because they might be doing different things on the left and right side. I don't know, that's what my conditions are telling me, right? So let's go look at it. Condition number 1 says that as I approach 3 from the left, that's in this pink area, the height of the graph has to approach 2. So here's 2. Okay, so I can draw this graph several different ways. Maybe my graph is going to be vertical as I approach 3 and always be a height of 2. And then I would put a hole there because at x equals 3, it's actually defined down here at negative 2, right? But this could be a possible way my left-hand side of my graph could look. I could also have the height of the graph steadily decreasing, getting closer and closer to that height of 2 there, just steadily decreasing. Or maybe it's, it's increasing. Maybe the heights of my graph are going up and up and up and up and approaching that height of 2 on the left. I don't know, I'll just stick with this one since it's the last one I drew. So I'm going to draw my graph where my heights are going up, 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 up. It's getting closer and closer as I approach x equals negative 3 there on the left. The heights of my graph, if I plug in a negative 1, my height's way down here. And then I plug in a 0, my height's creeping up a little bit. And I plug in a 1, I'm getting closer. I plug in a 2, my height's up here. I plug in really, really close to 3, like 2.99. See how my height's really, really close to 2. So this graph meets that condition of having the limit of the function or the height of the graph approach positive 2 from the left. Okay, so I'm going to erase that pink shaded area because we have taken care of condition 1. Now we're going to focus in on condition 2. Condition 2 says as I approach 3 from the right of the graph, so as I'm getting closer and closer to 3 on the right, the height of the graph needs to be down here at negative 2. And again, there's lots of ways my graph could look. Again, I could just do a horizontal where the height is always negative 2. So, you know, if I plugged in 4, the height would be -2. If I plugged in 3.5, the height would be -2. I got 3.001, the height is -2. So that's one way my graph could look. Kind of like how that looks, but we can draw it other ways. You know, I could draw my graph where the heights are getting steadily higher and higher and higher and higher and approaching that height there, you know, of -2 as I get closer to the input x equals 3. So, you know, my graph could look like this. Or maybe we want our graph to do, let's see, maybe we want our graph to be way up here and then steadily falling and getting closer and closer to height of -2 on the right. You know, my graph could look like that. So lots of ways our graph could look. I don't know. I'm going to go back to that first way. I kind of liked how that looked. I'm just going to do this horizontal line here. There you go. Okay, so let's make sure we've met all of our conditions here. Okay, so let's go back to our 3 conditions. Okay, let's make sure as we approach 3 from the left, our height of the graph is 2. So here's, you know, x equals 3. I'm going to approach it from the left. So my heights are increasing, 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 and they're getting closer and closer and closer to a height of +2. So we met that condition. And now we're going to make sure as we approach 3 from the right that we're reaching a height of -2. So let's make sure we're doing that. We're going to approach 3 from the right. And here my height was steady. It was always -2. So I'm definitely approaching a height of -2 from the right. And then we need to make sure that as I approach an input of 3, the height of the graph is -2. So when x was a +3 down here, I have a solid dot at -2. And I put a hole up here because I can't have my function defined at both -2 and +2 when x equals 3. Then it wouldn't be a function. It would fail the vertical line test. So I just put a hole up here at a height of +2 and a solid dot there at -2 because my function is defined to have a height of -2 when the input is 3. Okay, so I met all my conditions. Great. Now I can answer this last question about the limit. Well, without even drawing this graph, I know that this limit does not exist because for the limit to exist, the height I approach from the left has to match the height I approach from the right, and these two heights do not match. There was a jump in the graph there when x equals 3. So this limit definitely does not exist as we approach the number, the input +3 from the left and the right, because the heights of the graphs do not match. Okay, so you're going to see a question like this on your take-home quiz. Don't hesitate to reach out and ask if you need some help.